Dear engineers, we have completed a Etabs modeling and a final analysis. Now we'll go for a structural detailing of our column. So for completing our structural detailing of our column, or working by if you want to create working diagram for our column, then first of all we have to create group of our column. Okay, so for that I can take a output of a column section directly from here. Go to file and then export, then DXF or DWG file. What we want to output as a what we want to take as output: column layout plan, layer name. Okay, it's okay. Go for select floor. So for that I'll only take for Studio 1. Okay, and take it as it is. So okay, and I'll give a name of it, column layout. It's up to you that how will take your name. Then just click generate. File have been completed. File generation have been completed. And close. I'll go to our folder. And where is our file? We have to find out that. New folder, modeling here. See, here our file. I'll double click and open that file. Okay. See, here our column size is 12 inch into 20 inch. Column size is 12 inch, 20 inch, 12 inch, 20 inch. So why we have taken that output? Because as we have taken that output as a from our software, then we'll be directly used that output. We'll be able to use that output for any types of work now. So now let's start for our final work. And when we need, we change that name. First of all, we'll make some group. First, see here they have some name of our column, but we'll create some group so that we can make our detailing perfectly. I'll just go to our Etabs. I'll come here, and first of all I'll take that J section, J elevation. I'll click here and then elevation and J. We'll take that for J, H and I. Okay, so first of all I'll go for J and apply. Sorry, click here and click here. So this is our JG, that means that column. Then this is our another one, JD, that means that column. And for JB, that column, and for JA, that column. Clear? So when we are here, we'll see that what is the difference between our different columns. Now here we can see that our maximum reinforcement is 3.45 as per design. And if I right click here and if I just go for summary, 3.54, that means 1% reinforcement being used here. 15 divided by 23, and here 12 into 20. Okay, now 1% reinforcement is required here, also 1% reinforcement is required here. Column size of that point is 12 into 20. So the column size of, that column and that column, I will take it as a C1. C1. Also take it as a C1. Clear? C1. Now our let's just give here required reinforcement for that point. I'll take 3.45 from our design data. 3.45 plus 2.4 slash 2.4. Okay, done. Now I'll go for that serial. Here all column are 12 into 20. Then I'll go here, elevation, go to that section H, here H, also we have 3 column here, right? AH, that on our AH, then BH, then DH and FH. Clear? We have that 4 column, and we can see here that one or that one same as our previous. So what we can do, we can take that 2 column as a column 1. So I'll go to our AutoCAD, and for that column, and in that column I'll go for column 1. Clear? And for that one I'll just go for column 2, and for that one also for column 2. And here, what is our reinforcement? If we see here, maximum reinforcement of that section are 5.44. See here, 5.44. So I will take it 5.44 slash 2.4. Why 2.4? In above story will provide less reinforcement, because here less reinforcement are required, and I will mark it as a story 3, so that we can understand till 1 2 3, till 1 2 3 we need that reinforcement. Done. Now I'll go for that side. Now click here, go elevation, and for I elevation, go here, and you can see all of our section are working well with our column 1, so we can identify that all column as a column 1. Clear? So column 1, column 1, column 1. Now I'll go for that 2 column. So again I'll go in Z elevation, Z, and then apply, then okay. And if you don't know how to use Etabs software, then you can watch our previous lectures from our channel, or you can visit our website to join our professional course, and you'll be able to learn Etabs professionally. You see here is the main decision we have to take in, as my structure is only G plus 5 story, and we have to, we had to provide it, we had to provide a special case of combination as per our code. So but for that structure it will be normal condition. So for normal condition, what we'll do actually, we'll go for less reinforcement, not much more, 13.907. okay, not much more. So I'll only consider the reinforcement of that column or 10" for that, for or till 3 story, then above I'll provide we required as usual. So I'll provide 10" square for C3 and also also C3, and for C3 we'll provide 10 till 3". 10 till 3 feet slash 2.76 in above. Clear? So we have completed our reinforcement requirement here, where at which column how much reinforcement we need. Now I'll go for our next step, our detailing step. So for that I have a detailing for course detailing practice. Okay, and if you want to learn these things, you can also visit to our website. So I'll double click here, and I have every shape available here, and from here I'll just copy it. I'll copy and I'll go to here. So see here our data, and what I'll do, I'll change that background color, because at least we'll print our every work in white base. Okay, done. So when everything is okay, now we have only 3 columns, C1, C2, C3. So I'll close that on, and what I can do that, okay, it's done. Now below GL we have to use clear cover range, and above floor level or formation ground level will provide 1.5" clear cover. Okay, C1, C2, C3. So our column size of our C1 column size below GF, what will be our column size? C1 12 into 20. So our So 12 plus 3 clear cover and 23, it's okay. 12 plus 20, 12 into 20 inch, okay. Okay, so everything is okay. Now here we have divided that below GF to first story, second to third story. I have taken multiple section here because, and if you need that detailing sheet or anything, just you can visit our website. Here everything is available. You can join our professional detailing course for that. Now see, now what we'll do actually, why I have taken that section, because I want to use reinforcement very less in above and high in bottom as per requirement. If I take one or two section, then it will be very imbalanced. So first of all, I'll go for that column. Now I'll use the Excel sheet, design parameter Excel sheet. This is also available to our website, link given in description and first comment. And I'll main river calculation. So for minimum river calculation, sorry, not minimum river calculation, we'll go for river spacing. River, here we'll use that option only. So our required reinforcement are for Xion 3.45, this is 1%. Okay, this is 1% of that section. So I'll take minimum 1.3%. So 3.45 into 1.3, 4.48. So I'll take, or 3.45, 1.25, 3. I will take that value for our column 1. Okay, done. Now how we can resolve that? If we provide 0 nose 20 mm river and 10 nose, if we provide 10 nose, or okay, we have to take one thing. Our above floor reinforcement was, the reinforcement above first floor was 2.4. So 2.4 into 1.25, that means 3. So we'll consider 3. Consider 3. Okay, just see, if we provide 10 nose 16 mm river, then our reinforcement will be fulfilled above first floor. But below first floor or below grade beam, we need that reinforcement. Clear? Now what I can do that, I'll just go to our detailing. If we provide reinforcement, so if we provide 10 reinforcement here, what happens? See, now here 1, 2, 3 and 4. Okay, then 6, 7, I mean 5, 6. Also we need 4 reinforcement. So what we can do that, we can use reinforcement here 1 and here 1 and here 2. Okay, so in that side it will be 448, and here 110. Clear? Now if we take 10 reinforcement for above first story, it will be okay. 16 mm 10 reinforcement. So if I write here, so 10 and 16 mm rebar. Clear? Now for that section, what now if we provide two I mean 20 mm 2 reinforcement, then sorry, we have done a mistake here. We'll provide that one, and here some okay. So we need 4.31 inches for reinforcement, and we have provided that reinforcement. Also we need 2.22 inches for reinforcement. Okay, so here one thing we can do, we can use 20 mm reinforcement, and for above a story we can use suppose 6 or 420 mm reinforcement, and for 16 mm reinforcement, it will also be okay. Okay, it will be okay. But here one thing, just see, we'll go for another thing, that is it okay or is it economical to use that. So see here 9.4 if we use 4 number 20 mm, it will be 19.4. and if we just go here for 8, for 6, for 7, okay, just take 6. So here almost same, 19.94 and 1.86, it's almost same. So now we'll go for weight calculation of both reinforcement. For weight calculation, I will provide 20 mm 4 and 16 mm 6. 16 mm 6. So if we provide suppose 7 reinforcement, 16 mm 6, if we provide 6 reinforcement without using 16 mm 6 reinforcement without using 20 mm 4 reinforcement, see its weight will be 170 and its weight will be 1 on 209. Okay, so it will be. Now in taka, if we convert that weight in taka, so it will be almost 10,000 and it will be almost here, and its total taka will be, and if we just see what will be our that recent taka, it's a difference. See, it's 10,000 and 487 and it's 184552. Okay, even we are using more reinforcement than 20 mm, its price is less. So always you have to, it's only 4 reinforcement. So if we use here 1000 reinforcement, and if we use here so it's 4, so if we go for 400 and if we go for 600, just see they have a far difference almost. If we just see the difference, see 43,000 taka, 43,000 in I mean in our country currency. So it's, and when we go for a big project, it will vary, it will really vary. So what I can do that we can use I always prefer 16 mm reinforcement in column for that types of small structure. So I think it will be okay. So what I can do that I can go for but in this case we're helpless, we have to use these types of arrangement. So now what we can do that we can go for this arrangement for our above column, not for below. For below we can go for 6 and so we can go for 8, and if we go for 8, then maybe it will be okay. See, 44 inch we require 4.3 on, and we are providing 4.4 inch, so it's okay. So we can go for 20 mm for reinforcement and 16 mm 8 reinforcement. Clear? So we need total 12 reinforcement for bottom, I mean below grade beam. So what I'll do here we'll change it, but I'll go for that arrangement. How? I will take 10 reinforcement here, 10 reinforcement here and here. So now what was our actual requirement actually? Do you remember that? Our actual required was 3.85, and here we have provided here 4.09. I think it's quite okay. Okay, it's okay, and if we can maintain that percentage, it's okay, it's very okay. But this percentage is also okay because we need only 3.45 and we have provided 4.09, so it's okay. And for above story it's okay. So now I'll go here and here I'll write 10 16 mm 5 plus 2 20 mm percent C5. Clear? Here and above will provide that arrangement. So what I'll do, I will delete that reinforcement from here, and the person who will complete this detailing, he will arrange that. And here it will be available. So a total 5 5 10 and 1. So for that on and for that on we will use for 20 mm till our GF level, and then we'll not use that column or that reinforcement, and you will move that reinforcement, then that reinforcement little bit inside, and it will be okay. So how we'll just arrange that? I'll move it like that. Clear? So it's okay, it's done. And the Excel file we have used here, if you need that, this Excel file is available on our website, so you can download it from our website. Okay, now we'll go for our shear reinforcement, that shear reinforcement. So for that I will also use Excel file as per ACI code. So let's do it. Here we have some Excel file in our E series of E. If you visit our website and if you go to our resources section of our website, then you will find that Excel sheet. Now what we need? Shear reinforcement calculation for column. Here for shear reinforcement calculation, I will just the previous thing we have done in our another Excel sheet, also you'll be able to do it here. So now our column size, what is our column size? 20 into 12. Clear span. So what is the clear span? Clear spans mean from floor to beam height, of our column. I mean that column portion which are clear and they have nothing is connected with it. So it's almost 8.75 for our case. And which types of frame we are going to design? We're going to design a frame of a special moment resting frame. Then Fy, so yield strength of our reinforcement, it's 72.5. Leg number of tie. So what is the leg number of tie? If I just go here, so here if you see they have three portion, 1, 2 and 3 portion of tie. So we'll tell it as a 3 leg, and here we have 2 leg. So here and here, or here and here, 2 leg. So we'll take it as a 2 leg. And then required shear rebar. So I'll just go to Etabs, and from here I'll go to design, display design, then shear reinforcement, apply. You see, we can see here our shear reinforcement. Now you can see here the maximum shear reinforcement are showing. So we'll take the maximum one from here, and the maximum value of that are showing here, 0.6963. No, sorry, not for that column. We will go for our that column. Here we record 0.2, here also 0.2. Then we'll go for another portion. Here it's showing 0. It's also for, I mean that section are also for that column and that column. I mean B. We need, okay, just we'll go for, first of all go for J, and in J it shows 0.336 maximum. Okay, then for H, here, so 0.336 is also maximum. In I, 3239, so 39 is maximum. So we'll provide 39. Let's just go here. Our required shear info 0.39. Okay. And dia of shear bar 10 and dia of a smallest long bar 16 mm. Clear? 16 mm. So here we have found that our left side will be 3, middle will be 6, and right side will be 3. And our, I mean, what is that actually? Side means here. So here it's represent, this is the middle part, and you have seen the value of 20 inch. That means our that is straight up, and that is straight up. This, I mean, till how much distance will take that 3 inch spacing till 20 inch. So if you come here 20 inch, that's why I have provided here 2 inch. So from that point to that point, from that point to that point, I mean, till that point we have to provide reinforcement till 3, I mean, for 3 inch, and here at middle portion we'll provide for 6 inch, and where we have lapping we'll provide 4 inch. Clear? So this, just come here, double click, it will be 6 inch. So let's take it 3.5 inch, 3.5 inch. Double click here. Done. So in this way I will complete my detailing for C2 and C3. Now if you have any question or any problem, just let me know, or for learning professionally, just visit our website and join our courses. And if you want to support us, then you can join as a educational access membership, and you can take educational access membership, or you can give us super thanks. So thank you very much. And for that documents, please visit to our website, it will be available there. Thank you very much.